tell you this right now. We're recording. I guarantee that I'm giving you at least 6 questions that will be on the test. I guarantee it. Not just counting the easy ones like what are the units per period, what are the units per frequency. Because those will probably be on there too. Alright? Okay, so period is just the fancy word for time. The time it takes to go around in one revolution is period. We're still going to use the letter T. The units are still going to be what? Seconds. Right. It's still time, but it's just the time it takes to make one complete revolution. Easy enough? Cool. There's also frequency. And frequency, for some reason people think frequency, a lot of people have thought that frequency is the same thing as velocity, and it's not. Frequency is much more similar to time. It's just the flip of it. Okay? The units for frequency are going to be hertz. But frequency is just the inverse of time. Instead of how many seconds it takes to do one revolution, frequency is how many revolutions it does in 1 second. So it's just the flip of it. Okay? It's how frequent something happens in 1 second. Especially in this class, it'll be in 1 second. Okay, so 1 hertz is really 1 revolution per second. Okay? Alright. So you're going to have times where I give you period and you need frequency, and you'll just do 1 over your number. Or I'm going to give you frequency and you'll need period. It will be the same thing, 1 over that number. Which doesn't mean, it means it's not the same number. 1 divided by 5 is not 5. 1 divided by 5 would be 0.2, right? For frequency here, let's say it takes a half a second. So the period is a half a second. It takes a half a second to do 1 complete revolution. What would frequency be? 2, yeah. Yep. Because if it takes a half a second to do 1 revolution, it does 2 revolutions per second. Okay? That's the idea behind it. Okay. Don't copy that down. We just talked about this as a warm-up. The idea is that we're leaving straight lines and going in circles. So instead of distance over time being velocity, we have to think in terms of circumference. So 2 pi r is distance now. So the idea of the formula, if we don't copy that down either, because you should hopefully have that, velocity is distance over time. Since v is d over t, but we're dealing with circles, the new formula for velocity, which we will call linear velocity, even though it's going in a circle, we're going to call it linear velocity, because if any second I release it, it would go in a straight line and it would be this velocity. The linear velocity when something's going in a circle is 2 pi r over t. And I'll pause for you to copy. Okay. Here are possibly 3 questions you might see again. I wonder if you want to copy these down. You can do whatever you want. Let's say I have another ball attached to the middle of the string here. So they're both attached to the same string and I'm spinning it around. Here is your first question. Which ball will have the greater period? The inner ball or the outer ball?
The inner one.
The answer is both. They will have this. They will both have the same period because they're attached to the same string. So they will both take the same amount of time to go around a circle. Okay?
So what was the question?
The question was which ball will have a greater period, and the answer is they will both have the same period. Okay? Second question. Which ball will have a greater frequency? Both. They will both have the same frequency, because if they have the same period, then they have the same frequency. They both will take the same amount of time to go around the circle. They'll take the same amount of time to, or do the same number of revolutions per second. All right, the last question. Which ball will have the greater velocity? The outer ball. Okay? Why is it the outer ball?
It's traveling.
Does it go for the distance?
Yeah, exactly. it's going a longer distance the same amount of time. So the outer ball will have a greater velocity because it's traveling a longer distance the same amount of time. Okay? So the ball with the longer path would have the higher velocity if they have the same time. But that leads us to the idea, in sports especially, where increased radius will give you a higher velocity. Okay? If I'm going to golf and I want to have a big drive, I'm not going to have a drive swinging like this. Okay, that would be for putting. If I want to have a big drive, I want to make sure I extend myself out in the swing. Okay? For hitting, the same thing. For throwing, a pitcher is not going to be throwing like this. Right? A pitcher is going to make sure that he has his arm extended to have the highest radius and the highest velocity. Alright? So with that in mind, that's why some pitchers, Randy Johnson, who used to pitch, when I did the slide he did pitch, why Randy Johnson, one reason he's such a great pitcher is because his arm is so much longer. So if I can rotate my arm as fast as Randy Johnson, but his arm is twice as long as mine, the velocity in the ball for him is going to be twice as fast. Okay, so that longer arm is a higher radius and therefore a higher velocity. Okay? Okay. I'll pause here. Question that you really want to know. Let's say I'm spinning this ball in a circle and I have a razor blade right here. So I'm going to cut the string right at this point. Make sense? Okay? Or you don't know why I'm doing that, I guess. Here we go. So I'm spinning this ball and I'm about to cut the string right here. Which direction do you think the ball will go in? A, B, or C?
C. S.
Okay. The correct answer is C. Okay? At every point in a circle, an object will want to go off at a straight line. Alright, at a tangent. And at every point, the string is going to pull it back in. Okay? So at every point here, the velocity wants to go off on a tangent. And we pull it back in with the string. Okay? So if I'm spinning this ball, it feels like it's going to pull. It feels like it wants to go out. But it doesn't. It wants to go, it's always going perpendicular. It's always going in a straight line, and it keeps getting pulled back in. Alright, so we call this, you want me to wait a second to record? Or to copy that down? Because maybe spinning a circle, we call it the velocity tangential velocity. Okay? I think someone was already mentioning something about tangents for math class today. When something's spinning in a circle, it will always want to shoot off. It always is aiming, or the direction of the velocity will always be perpendicular to the string. It always wants to go off here, and at every point it gets pulled back in. So at every point in the circle, in the path, the velocity will be perpendicular to the radius, going off at a tangent. Okay? So the velocity will always be perpendicular, and that means that the velocity is constantly changing. Does that make sense? Again, you don't have to copy this down word for word. You want to make sure you remember the word tangential. Okay, you want to remember where tangential points, just in case that's a question. Tangential will always have to be perpendicular to the radius. Okay, and that means wherever it's going to shoot off will be off tangent to the circle. Okay? Are we still recording? Alright. Maybe that part should have been recorded.
You said don't take notes.
Say it again.
I'll say it again, just in case we weren't listening. Because the direction is changing when something's spinning in a circle, even though the speed is not changing, if the direction is constantly changing, that means the velocity is constantly changing. Therefore, you have acceleration. And this is the acceleration we want to talk about today, the centripetal acceleration. Alright? Centripetal means towards the center. Alright? So acceleration, when something's spinning in a circle, acceleration will always point towards the center. Centripetal means towards the center. So whether we're talking about centripetal acceleration or centripetal force, notice how I just have a little sub C next to A for acceleration, a little sub C next to F for force. So either centripetal acceleration or centripetal force. The arrow will always point towards the center. Now here I am Nostradamus. You ready? I'm looking into the future to your test corrections. I see a student coming up to me and saying, how come the answer to centripetal force or to centripetal acceleration, how come it's the one here? And I'll say, well, centripetal means towards the center. So the arrow you should have picked should have been the one that pointed towards the center. And they'll say, oh yeah, you told me that during the lecture. And I'll say, yes. Yes, I did. Sound good? Okay, now, here's the part that's a problem for people, though. I bet you if you went home right now and told your parents that you were covering centripetal acceleration, some of your parents would say, oh yeah, centrifugal. I know all about it. Centrifugal is not a force. It's a phony force. There's no such force that pushes out. There's no such thing as centrifugal force. Okay, when you take a hard corner driving your car, you feel like you're getting pushed out, right? But you're not. Has anyone been on the Gravitron or any other amusement ride where you're spinning around in a circle and you feel like you're getting pushed out? Okay, that's the same thing as Gravitron. You know what I'm talking about? You're not getting pushed out. You just want to keep going off at a tangent and you keep getting pulled back in. Okay, let's say I'm driving along and I want to take a hard right turn. So I'm driving along and I take a hard right turn. My car goes that way. I'm not gonna get pushed out that way. Right? That won't work. If I'm driving along in a straight line and I take a hard turn, I just want to keep going in a straight line. But the car is going to pull me back in. So I feel like the car is pushing, because I feel the car pushing me in, I feel like I'm getting pushed out. Where I'm not. I just want to go in a straight line and the car is pulling me in. Does that make sense? So that feeling on the Gravitron, spaceship, whatever it is, it's you constantly going out in a straight line and getting pulled back in at every point. Alright? There's no such thing as centrifugal. There's a centrifuge. Alright? There's a machine that spins things around so they can settle things and separate stuff. But it's not any force that's being pushed out. It's just that at every point, the object wants to go in a straight line and it's getting pulled back in. Okay? You feel that force, you feel like you're getting pushed out, but you're not. Same with spinning. Ever have the bucket spinning water? You spin a bucket around in a circle, okay? And the water stays in the bucket the whole time. That's not that there's a force pushing the bucket of water or the water out. It's just that the water wants to keep going in a straight line and you keep pulling it in. That's what centripetal is. That's what centripetal force and centripetal acceleration is. Okay? Alright, and here's a force formula. There's centripetal acceleration formula. What are the units going to be for centripetal acceleration? Meters per second squared. It will not change. The units will not change even though we put a word in front of it. Okay, so it still will be meters per second squared for acceleration. What do you think the units will be for centripetal force? Newtons. It won't change. Okay.